Guys, Mr. Themes coming at you one more time with our one last episode for B208 Math. Don't forget to like and subscribe to my YouTube channel. If you ever want to come back and get some more math lessons in, you know where to find me right there on YouTube. Today is our last lesson, and today we're going to be learning about solving linear systems by graphing. The learning targets we're looking at today is we're going to convert linear equations into slope-intercept form. Guys, do not forget slope-intercept form is y is equal to mx plus b. It is very important you remember that the m is the slope. This is the slope of your line. And then your b is what we call the y-intercept, or where the line crosses the y-axis. We're going to be able to convert these equations into slope-intercept form because not all lines are written in slope-intercept form. Just like this example right here. Let's go ahead and look at this example right here. This example A says solve for y. So step number one, to get y by itself, to isolate y, let me go ahead and rewrite this. Please write this down on your paper with me. 3x minus 4y is equal to 16. To get the y by itself, the first step that we need to do is do inverse operations, and we're going to subtract 3x to both sides. We want to get the y all by itself. We want to isolate y, so my balance line is there. I'm going to subtract 3x to the left, and I'm going to subtract 3x to the right. Then I'm going to have negative 4y is equal to negative 3x, and this is like a plus 16. So that these are not like terms. You can't put those together. You got to keep those separate. Step number two then is we're going to use inverse operations, and we're going to divide both sides by negative 4. To get the y by itself, you got to get rid of this negative 4 here. We're going to divide this whole thing by negative 4, which, guys, is essentially the same as dividing both this term by negative 4 and this term by negative 4. So either way you want to write it works, because you're dividing them both by negative 4, which then should get your y isolated because these two negative 4's cancel. This will become a term, and this will become a term. We can simplify that, so it would be y is equal to negative 3 divided by negative 4 would be a positive, so it's 3/4 x, so that's our slope, 3/4, and then 16 over negative 4, that's going to be a negative, and that's going to reduce to 4. This would be the equation of our line in slope-intercept form, which is our first learning target right here. Our second learning target that we're looking at is we're going to be able to solve systems of equations, systems of linear equations by graphing. So let's take a look at this example over here. This graph shows us the height of each student's height from August, which is A, all the way to May. So you'll notice this first student, let's just call him student A, starts off much lower, much shorter, but is growing faster. Boom. Student B starts taller, but it's not growing at the same rate, but from August, beginning of school, to May, the end of school. But the solution to this is this point right here, where these two lines intersect, or in this case, where these two students are the same height. That is the solution to the graph. Those are the two skills we're working on today. Let's look at the first examples. Try these A. So we need to solve these equations. So it says solve equations for y. So we got to get y by itself. We're going to remember to always draw your balance line, get the y by itself. The first thing we're going to get rid of is this minus 8. We're going to subtract 8 to both sides. So those x's will cancel. We have y is equal to, guys, remember, this is a x and this is a number. These are not like terms, so we're just going to keep it negative x or negative 1x. And this is plus 8. This is now solved for y. We could graph this line with our y-intercept of 8 and our slope of negative 1. For B here we're going to solve again. Solve for y. So we're going to subtract 2x to the left. We got to then subtract 2x to the right. So our new equation then would be just y is equal to negative 2x. And then that's plus 6. That would be our equation solved for y. For C, so you'll notice that here then, you know what, I'm going to skip C. I'm going to leave that one for you. I'm going to go ahead and jump down here to E, the hardest one. So the hardest one for E, we need to solve for y. So the first thing, this is actually a multi-step one. We're going to subtract 4x to get the y by itself. First thing you have to do is subtract 4x. So then we're left with negative 2y is equal to negative 4x plus 4. Now, second step now is we have to divide by negative 2 again. Divide by negative 2, each one of those terms by negative 2, so you get y is equal to, let's see, negative, I'm going to go ahead and circle this so you can see, it's negative 4 divided by negative 2, which in this case would reduce negative 4 divided by negative 2 would give you 2x, and then it is 4 divided by negative 2, so then that would give you, let's see, minus 2. That would be the equation in slope-intercept form. We have our slope of 2 and our y-intercept of negative 2. Please press pause and do both C and D right now on your own. The next example, you can see it says each of these 3 figures below is a graph of a system of equations. Identify each system of equations as having one solution, no solution, or infinite many solutions. Looking at graph number A, they intersect right here. There's one point where these two graphs intersect. That is the point of solution right there, which in this case, the coordinates would be negative 3, 0. It has one solution, so we need to write one solution below this. The second graph, next over to the right, you'll notice it is one single line, but there's actually 2 lines that are just have the exact same slope and the exact same y-intercept. When there are 2 lines that are basically sitting on top of each other, that is going to be called infinitely many solutions. Infinitely many. 2 lines directly on top of each other. For graph number 3, notice how these 2 lines never intersect at all. They're parallel. They have the same slope, which is a negative slope, but they have different y-intercepts, so they're never going to intersect. Therefore, there are no solutions. Please press pause, flip your paper over to the back side, and figure out whether it is one solution, no solution, or infinitely many solutions for graph 1, 2, and 3. Press pause now. Okay, now we're going to go ahead and graph these lines, and we're going to find the solution on our own. So the first one, we have the first graph, we can figure out this is the B, and this is the M, so our B is our y-intercept, so this line would be at negative 4. And then we have a slope of 2, so rise 2, run 1, rise 2, run 1, 2, 1, 2, 1, 2, 1. We can go back down 2 and left 2, so then I'm going to plot this line here, and this line is going to go right through there. I don't like that color. I'm going to go ahead and plot this line, and I'm going to have it go through all of my points, and it's going to go through there. The second line then that I'm going to go ahead and plot is going to be, I have a y-intercept of positive 1 because our b is 1, and our slope is negative 1/2. So I'm going to go down 1, run 2, down 1, run 2. Notice this one has a nice easy point of intersection for us. It's going to go ahead and it's going to intersect our line at this point right here. Boom. So determine the solution. The solution in this case would be this coordinate, that coordinate right there, which is going to give us a coordinate or a solution of 2, 0. Press pause and please do the next one over here on the right on your own. And finally, we're going to go ahead and solve these equations for y, so we're going to graph them first. Notice how this equation right here, the top one is not already solved for y, so we need to go ahead and rewrite this. So first thing we're going to do is subtract 2x to both sides. So then that would give me negative 3, just like we did on the front side. Negative 3y is equal to negative 2x minus 1. Okay, now we're going to go ahead and divide both sides excuse me, by negative 3. On my balance line, divide by negative 3, divide by negative 3. So that would give me then my new equation is y is equal to 2/3 x plus 1/3. So now this equation is this equation right here. Let's graph this first one that I just solved for. So my y-intercept is 1/3. So this is 1/3 is about right there. And my slope is rise 1, 2, run 1, 2, 3, rise 1, 2. You got to kind of be careful on this one because it's not directly on the line. It's actually a little bit below the line. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. So you'll notice that this is going to still be a straight line, and that's our y-intercept. Our points are going to go through here. That's the first line. The second line then that we'll plot would be this equation here. So this again has a slope of 1/3. And notice that it has a y-intercept of 1/3, and our slope again is 2/3. So rise 2, run 1. Rise 2, run. What you should notice that these points are exactly the same. So, which means this line is actually also going to be exactly the same. They're going to lay on top of each other. When that happens, when you have two lines that are directly on top of each other, it, again, is when there's infinitely many solutions. Infinitely many solutions. Please press pause and do this one over here on the right on your own. I want to congratulate you all for making it through my lessons. Thank you so much. Hopefully you learned a little bit. After you do this one on your own, I want you to do the IXL lessons and continue practicing. Good luck, best wishes, continue to love math. You can do it.